Hi, my name is Aksara.
Hi, my name is Naman, and today we are presenting a multimodal model on Edge. We have built an Android app which does near real-time zero-shot object detection. So the idea here is we are leveraging edge computing to do a real-time image detection, and for that we are using a multimodal model called Grounding Dino. And on the edge, and on the client side, we have an Android application. Now, to talk about the existing work, Akshara will tell on what existing work we are building up app on.
Yes, thank you. So the existing work is, as we've mentioned before, is Grounding Dino in the Gabriel platform. So Grounding Dino is a state-of-the-art open set object detection model that provided an image and an object to detect, it will return the image with the object boxed. So it's just a zero-shot AI model. And then the second existing work that we used was the Gabriel networking platform. So this is just a framework that we used for low latency networking purposes to connect the application, and in this case, the Android app, to the cloudlet that we were using. And then going into the design architecture, so the Android app that we've created is a multimodal application. So you can either give it an image or a video input, and then for the object to detect, you can provide that through speech, and it will perform speech to text, or you can just give it text explicitly. And then it will use the Gabriel framework to send these inputs over to the cloudlet that is hosting our Grounding Dino server, and it will perform the zero-shot object detection and then provide that image back using the Gabriel framework again, and the input will be displayed on the Android app.
So just to touch upon the architecture, the details of the architecture, on the cloudlet, we have a hardware accelerator, and we have a 1080 Ti GPU from NVIDIA, which actually helps us accelerate the computationally intensive AI inferencing of the Grounding Dino model. And this actually enables us to get a latency which is almost near real time, around a 2-second latency. And with the help of this, we can prove that the near to real-time edge inferencing is possible on Android client if we can leverage cloudlets. Now we'll have a quick look at the demo of our application.
Sure. So, like I said, it can do image or video detection, or any kind of detection, or auto captioning. Oh, sorry. This application can either do image or video detection, or can do auto captioning or detection. So right now, I have it set on image, and I have it set on detection, and I'm asking it to detect a person. So Naman, if you could be my person to detect. Just entering that input, and it's super faint, but you can see that Naman has been boxed. And then I can also do this as a video input, so it's just detecting, it's a video that it's detecting a person in multiple frames, so you can see that the box stays with him and it keeps moving with him. Changing that back to image, I can also do auto captioning. So right now I have it on auto captioning, if it will go. Yeah, and then right now it says that in this image it detected a person and a chair. So yeah, I mean, there are also chairs behind you. Oh, I can do just chair, and then it says that the image contains just a chair. And then you can also do chair, speech to text. I'll go back to detection, and it inputted chair as the object to detect, and then, yeah, and then it's detecting the chairs, which are all boxed. Yes.
So as we saw in the demo that our app works in both the modes. It can take input the text-based prompt as speech to text, or the user can type it out. And then it takes another mode as the vision mode, the camera feed. It can be a video feed or a still image. It takes both the inputs, use the Gabriel network and sends it over to the cloudlet. And the cloudlet does the processing part. Now, Aksara will talk about the challenges and learnings.
Yes, thank you. So first we wanted to talk about the learning curves that we had to get past. Neither of us had done any Android programming or creating an app or inferencing an AI model or using a networking framework. So a lot of the steps we had to do for this project were completely new to us, and there was a huge learning curve, but we were very excited and we ramped up pretty quickly. And yeah, I think the next hurdle that we had to face was containerization. Once we got all of the components that we had to learn about working, we had to containerize it so we could deploy it on a faster machine. Instead of the cloud that we were using in our testing, we wanted to deploy it on a Lambda cloudlet, which was much faster. So one of the things we had to do for that was containerization, and that was a lot more difficult than we realized. And then the reason we had to do containerization to begin with, like I mentioned, is because we wanted to move to a more computationally able machine. So another challenge that we had to face was that the first machine we used was a cloudlet with limited GPU, and it had trouble doing real-time inferencing. So so a lot of these are intertwined with each other. And then at the very end, one of the goals that we had was to publish this app to the Google Play Store. And we've done internal testing so far, but one of the mandated requirements for publishing to the Google Play Store is that you want to test with 20 users for a minimum of 14 days. And we weren't able to finish the closed set testing by the time that we wanted to present this, but we have done internal testing, and the app is also available for download through an APK.
So finally, talking about the road ahead. In the future, we already implemented speech to text. We might extend this and integrate our app with Google Assistant or any voice-based assistant on the phone, so that it provides the user a more seamless experience to use the app. And as Aksara mentioned, we have already docked the project. Now we can experiment moving our cloud or the server to a more computationally intensive, bigger machine. We can even move it to a cloud or a AWS instance, and then do this analysis of measuring the different time it takes, processing time based on different architectures. And we can even do a hybrid architecture where we are opportunistically offloading the workload from cloudlet to the cloud. And finally, once our closed phase testing is done, we'll publish our app on the Google Play Store so that anyone in the world can download it, and it will help us do extensive user testing of the app. And we'll finally document our progress so that people ahead can actually take it forward from there. Thank you.
Thank you.